So this graphic really shows you kind of a breakdown of how you can convert between moles, grams, and atoms. Okay, so if you have grams, you're given mass of elements in grams, okay, you will first have to convert to moles in order to convert to atoms. Okay, now this is showing you that if you are going from grams to moles, you divide by the molar mass of the element. Okay, that gives you grams on the bottom that will cancel out with your grams on top. If you're going from moles to grams, you will actually multiply by the molar mass. Okay, that has moles on the top here, moles on the bottom. They cancel and leave you with grams. And then once you have it in moles, if you're going to atoms, you will multiply by 6.022 times 10 to the 23rd. Okay, you have moles on top here, moles on the bottom here, so they will cancel and leave you with atoms. And then if you're going from atoms to moles, you will have to divide by 6.022 times 10 to the 23rd atoms. Atoms on top here, atoms on bottom, they cancel, leaves you with moles. Okay? And then going from grams into atoms or atoms into grams, it just shows you the two-step process of going through moles. All right, so what is the mass in grams of 3.50 moles of the element copper? Okay, so first thing you want to do, because you are converting from moles to grams, you do need to know the molar mass of copper. Okay, so if you look at your periodic table, find copper on the periodic table, you see that copper has a molar mass of 63, oops, might help if I had a pen here, so 63.546 grams in 1 mole. Okay, so we have moles on the bottom here, this is going to be moles on top, so we can just go ahead and multiply them straight across. So it's 3.50 moles times 63.546 grams, and that gives us 222 grams of copper, Cu. Okay, so let's erase some of this here. All right, a chemist produced 11.9 grams of aluminum. Okay, so we're given grams. How many moles of aluminum were produced? So you have your 11.9 grams. Okay. Now, are we going to need grams on top or bottom? Need to have them on bottom so that they will cancel with the grams here. So again, look at your periodic table. See that aluminum has a molar mass of 26.982, and that's grams under 1 mole. Okay, so at this point you can do 11.9 divided by 26.982, and you will get your moles is 0.441 moles of aluminum. How many moles of silver are in 3.01 times 10 to the 23rd atoms of silver? Okay, so we're starting with atoms and we're going to moles. So we have our 3.01 times 10 to the 23rd, and that's atoms. Okay, now are the moles going to go on top or bottom? They will go on top because that is what we are looking for. Okay, so 1 mole on top, and that is over Avogadro's number. Okay, so now you do your 3.01 times 10 to the 23rd divided by 6.022 times 10 to the 23rd, and you end up with half a mole of silver. Okay, moving along now. All right, yeah, we already looked at that one. So what is the mass in grams of 1.2 times 10 to the 8th atoms of copper? Okay, so here we're starting with atoms and it's asking for grams. So remember, when you're going from atoms to grams or grams to atoms, you do have to basically make a stop in moles. Okay, so our first step is going to be to convert this number of atoms into moles. Okay, so we need to put Avogadro's number on the bottom, because that is our moles here. Or, sorry, that is our conversion factor here. And then it's under moles. Okay? And then here, all right, we've got atoms canceling here and here. Then we've got moles. We need the moles to cancel. So we've got 1 mole on the bottom here. Moles cancel. And we're going for grams, so we now just put in the molar mass of copper on the top here, and it's 63.546. So at this point, you have it set up where all of your units will cancel until you get grams. So now you can just do the calculation straight across. So you have 1.20 times 10 to the 8th divided by 6.022 times 10 to the 23rd, and then multiplied by 63.546. And that will give you 1.27 times 10 to the negative 14th grams of copper. So not a whole lot of copper. Very, very small amount. Alright, so up to this point we've been talking about the molar mass of just elements on their own. Okay, but you can also figure out the molar mass of a compound. It's relatively simple. Okay. Basically, you just have to figure out the molar mass of every single atom in the compound and then add them all up. Okay, so if you have CO2, all right, we've got 1 atom of carbon, 2 of oxygen. So if you look at your periodic table, you've got carbon is 12.011. There we go. Okay, and then you're going to add in the oxygens. Each oxygen is going to have the same mass, so you can just take your subscript and multiply the molar mass by that number. Okay, so the molar mass of oxygen is roughly 16. So we have 12.011 times, or plus 2 times 16. Okay, and that gets you 44.01 grams per mole is the molar mass of carbon dioxide. Alright, so looking at caffeine, stepping it up here. So we have 8 carbons, which are still at 12.011. Now we have 10 hydrogens at 1.008. We have 4 nitrogens, and give me a second, let me just double check that. It's 14.007. And we have 2 oxygens at 16. Okay? So 8 times 12.011 plus 10 times 1.008 plus 4 times 14.007 plus 2 times 16. Add all that up, you get 194.19 grams per mole. Okay? And that is the molar mass of caffeine. Alright, so what is the molar mass of iron oxide? So, start by pulling out your periodic table, finding iron, Fe. Okay? You'll see that iron has a molar mass of, okay, for some reason it's not writing, 55.845. Okay? You only have 1 iron, so you don't need to multiply that by anything. And then you're going to add in the oxygen. And there's only 1 oxygen, so you don't have to multiply that. So it's 55.845 plus 16. So that gets you 71.85 grams per mole is the molar mass of iron oxide. What is the molar mass of methane? Alright, so we've got carbon. So if you look up carbon on the periodic table, its molar mass is 12.011. Okay, plus you have 4 hydrogens, so 4 times 1.008. Okay, so 12.011 plus 4 times 1.008 gives you 16.04 grams per mole is the molar mass of methane, CH4. What is the molar mass of serotonin? Okay, so here we have 10 carbons, so 10 times 12.011, the decimal there, plus your 12 hydrogens, which are each at 1.008, plus your 2 nitrogens, which is at 14.007, and your oxygen at 16. Okay, so 10 times 12.00011 plus 12 times 1.008 plus 2 times 14.007 plus 16. So you add all of that up, you end up with 176.21 grams per mole. It's the molar mass of serotonin. Alright, so how many moles of water are in 24.3 grams of water? Okay, so it's a grams to moles conversion. First thing we need to do is calculate the molar mass of water, which is H2O. Okay, so we have 2 of our hydrogens, 1.008. Okay, we have 1 oxygen. So, molar mass, oops, there we go. Molar mass is roughly 18.02 grams per mole. Okay, and now at this point, it's just like we were doing several slides ago, where you have your grams, so 24.3 grams, and you have your molar mass. Grams need to cancel, so 18.02 will go on the bottom to cancel grams, and then you'll have 1 mole on top. Okay, so it's 24.3 divided by 18.02. You end up with 1.35 moles of water. Okay. And let me get an eraser here. Okay. So what is the mass in grams of 0.000142 moles of vitamin C? Alright, so first, find your molar mass. So 6 carbons at 12.011 each, 8 hydrogens at 1.008 each, and 6 oxygens at 16 each. Okay, so you calculate your molar mass. So go ahead and do that real quick. So you should have gotten that your molar mass is 176.13 grams per mole. Okay, so now we have our moles given in the problem. So it's 0.000142, and that's moles. Okay, multiplied by your 176.13 grams over 1 mole. Moles will cancel. That will leave you with grams. So you go ahead and multiply straight across. Okay. And you end up with 0.0250 grams of vitamin C. Okay. And we're going to have to stop here real quick, and we'll pick up in the next video.